Welcome to lesson 5. Today we'll be doing the sum of an arithmetic progression, or basically the sum of a series. If you remember, a series is basically adding up all of the terms of a sequence. For example, if a sequence is 1, 3, 5, 7, 9, a series would be 1 plus 3 plus 5 plus 7 plus 9, and so on. And today's lesson is basically about finding out the answer if you added up all of those terms. So story time, I guess a bit of a story just to introduce the topic. There's a story about one of the greatest mathematicians of all time, Gauss. I think that's how you pronounce his name. In elementary school, so in primary school, you could say around year 5, year 6, he would have been around year 6 level. In the late 1700s, Gauss was asked to find the sum of the numbers from 1 to 100. So 1 plus 2 plus 3 plus 4 plus blah 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 plus all the way to 100, right? Now the question was assigned as busy work by the teacher because, the story says, the teacher wanted a quick nap. But Gauss found the answer almost instantly by discovering a pattern. His observation was as follows. And remember, this is an 11-year-old. This is what he thought. He said, okay, well, the question is 1 plus 2 plus 3 plus all the way till 100, right? So this is how he did it. He mentally wrote out 1 to 100 twice. Once in order and once in reverse order. So he said 1 plus 2 plus 3 plus 4 and then wrote all that down. And then he reversed the order and wrote 100 plus 99 plus 98 plus all the way to 1. And he put each term on top of, like he put 100 beneath 1, he put 99 beneath 2, 98 beneath 3 and so on. And then he drew a line and he just added up all of the terms. So you see S plus S is 2S. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. So basically he added this with this and he got this. He got 2s is equal to, this adds up to 101. This adds up also to 101. And all of them add up to 101. And how many of these terms are there? There's 100 of them, right? There's 100 here. There's 100 here. So obviously there's going to be 100 101s. So 2s is equal to 100 times 101, because there's 100 of these. 100 times 101, right? You solve that. That is equal to 10,100, and divide by 2, you get 50. The sum of the numbers between 1 to 100 is 5,050. And that's pretty amazing proof for an 11-year-old. Okay, and Carl Friedrich Gauss, he was 11 years old at the time of solving this question. Now, why did I tell you that story? Well, the story of the last slide wasn't just a story, right? Gauss had in fact found a method to calculating the sum of an arithmetic series. The method he used is the exact method that we still use today. And this is what you're going to be learning as well. So let's say we have an arithmetic series as follows. A plus D plus A plus 2D, all that to a plus n minus 1d. And as you remember, this is every arithmetic series you can think of. You can write it like this, because it starts off with a, and the next term is plus d, you add a difference, and you add another difference to that, and the nth term, the last term, would be a plus n minus 1d. Now, if we were to add all of these together, what would the sum of these terms be? Well, let's start by writing out s is equal to, I'm going to write down every single term, just like Gauss did, right? A plus d, second term, plus the third term, plus all the way till the last term. And we add that to, we write this in reverse order, right? So s will be here. Now the reverse order, the last term will be first, the second last term, third last term, all the way till a. Now we're going to add these up. S plus s, 2s. A plus a is 2a plus n minus 1d. Over here, a plus d plus a, that'll be a plus a will be 2a, right? If you expand this, you get nd minus 2d, and you add d to that, you'll get 1d. 2d becomes 1d, right? If you expand it, you'll see that it works. It's actually the same thing. So 2a plus n minus 1d, and you get all of these terms. And how many of these terms are there? Well, there's n of them, because we said there's n of these terms. That's why it's n minus 1. For example, if there was 100 terms, this would be 100 minus 1, 99d, if there were 100 of them. But there's n of them, that's why it's n minus 1. If there was 100 of them, it would be 100 minus 1 which would be 1990. The first term plus 99 differences. But in this case, it's n minus 1. So you add these together, there's n of these. So there's n of these terms, so we just multiply by n. Exactly the same as the last slide. The last slide there was 100, so we did 100 times 101. And this sum up to 2a n minus 1d. There's n of these. Divide by 2, simple algebra. Divide this by 2, so it'll be n over 2. We just divided the 2 over to the right hand side, and that's the formula. That is the formula for the sum of any arithmetic series. Now, if you hate memorizing formulas, you can memorize the following line. The sum of a series is the average of the first and last terms multiplied by the number of terms. Another way to think of it is, we had the first term, we added the last term, right? And we got that. So you get the sum of the first term and the last term divided by 2, and then multiply by how many terms there are, and that'll give it to you. So the average of the first and last terms multiplied by the number of terms. Or you can just memorize this formula. It's up to you. Now the standard formula for sum of an arithmetic series is that, right? N over 2, 2a plus n minus 1d. And by the way, just note this is a plus tn, right? Tn will be a plus n minus 1d. So it's a plus n minus 1d. If you want to think of it another way, you can think of it like that as well. First plus last term. The last term in this case, you can think of it as tn. A plus tn. Or you can memorize the formula. Whatever you find easy, really. Now, this was obtained by adding the first and the last term, or by adding the second and the second last terms. And you could add the second term and the second last term, you'd get the same thing. You'd add the third term and the third last term, you'd get the same thing. But the most important thing is the first and the last term, right? Now, the reason I say that is, this gives us an easier formula which we may be able to use in some questions. Let A be the first term and L stand for the last term. So this is another alternative version. It's like the shortcut version of that. It's exactly the same thing as I've explained, right? Same thing. And the reason we have this formula is, in a lot of questions, they will actually give you the first term and the last term, and they may not give you the difference, they may give you the difference, whatever. The thing is, if you have the first and the last term, you can just apply this formula. You don't need to go through the really, really long way where you have to substitute all that stuff in and so on. Just do this, right? Now let's check if these formula work by testing them out on the problem Gauss was given. And we know it's going to work, but just for the sake of it, let's just see how it works. So this is the formula, the traditional formula, right? And we know there are 100 terms, so n is going to equal to 100. The first term was 1, and the difference between each term is 1. 1, 2, 3, 4, and so on. So let's just make the appropriate substitutions. N is going to be 100, so 100 over 2. 2 times 1 plus the 100 over here, 100, and the difference is 1. So we make the appropriate substitutions, simplify, and you get the same answer as Gauss got. 50/50, 5050, right? Let's say we use the alternative formula. Now, how many terms are there? N is how many terms? There's 100 terms, right? First term is 1, last term is 100. So 100 over 2, 1 plus 100. Put that on the calculator, you get the same answer. Now, you will need to memorize both formulas. They aren't optional. Both of these formulas, you will need to know them. And you'll see examples of questions where you won't have the difference. If you don't have the difference, you can't use this formula. You have to use this formula. And the HSC and trial papers, they will test you on whether you know both formulas or not. They can if they want to. Okay, let's see. The first term of an arithmetic series is 5, and the 12th term is negative 14. Find the sum of the first 12 terms. And please do try and give these a go yourself. That's how we learn. Not by watching me do maths, but you do maths. Okay, so pause the video if you want, give it a go. Alright, so they're asking us to find the sum of an arithmetic series. We have to find the first term, which is 5, and the last term, which is negative 14. Therefore, the relevant formula is, and see, they've given us the first term and the 12th term. And we have to find the sum of the first 12 terms, therefore 12 is the last term. So the A plus L, first term, and the last term. And we just substitute it in, there's 12 terms, right? The first term is 5, The last term is negative 14. Make the substitution, do it on a calculator, and you get the answer of negative 54. Very straightforward. As you know, the shortcut way did work really good. Okay, now find the sum of the 15 terms of the arithmetic series 3 plus 7 plus 7 blah blah blah. Now we don't have the last term, do we? So we can't use the alternative formula, we have to use the traditional formula, the normal one. So in this question we don't have the last term, so we can't use the shortcut formula. The formula we need to use is the sum of first n terms is equal to n over 2, 2a plus n minus 1d. So let's figure out the variables. So, n will be 15. We need to find the sum of the first 15 terms. So how many terms are there? There'll be 15 terms. And the first term is a, we know this. And the difference is 4. Now we can do 7 minus 3, we can do 11 minus 7, doesn't really matter. Both of which equal to difference is 4. So now we have n, a, n, and d. We have n, a, and d. Now that we have all the variables, we just substitute it in. Simple, straightforward. Every time you see an n, put 15. Every time you see an a, put 3. Every time you see a d, put 4. Put on the calculator, or you can do it mentally. It's up to you, really. It's fairly straightforward. 2 times 3 is 6. 15 minus 1 is 14. 14 times 4. 15 of blah, blah, blah. And you get the answer of 465. So the sum of the first 15 terms of this arithmetic series will be 465. And you can expect this type of question in the first, so it'll be in the multiple choice, or it'll be in question 11 or 12. Like, it's a fairly straight. It can pop up in the HSC. It's a valid question. It's fairly straightforward. All right, work out the number of terms in the following arithmetic sequence. Now, in the formula, right, we need the 3 variables, right? We need n, a, and d. They can have either of any of those 3 variables missing. That's how they vary the questions, right? Any of those variables can be missing. And in this particular question, n is missing, the number of terms. N is missing. So we have everything else. We have the first term, we have the last term. We don't have the second, third, fourth, or any term, so we can't find the difference. So clearly we have to use the shortcut formula for this, okay? So we're going to convert what we have to variables. Now, s of n is 29, so we'll have first term is 1/5, last term is 28 over 5, s of n is 29, sum of the terms is 29. The number of terms we don't know. Let's just sub into the formula and see what we get. Alright, so this is the shortcut formula, by the way. 29 is equal to n over 2, a plus l. A in this case is 1 over 5, l is 28 over 5, right? And we just simplify. 1 over 5 plus 28 over 5, and you get 29 over 5. And you multiply that by n over 2. Simple algebra. 29n, 10 will be over there. 10 take over to the other side. Divide both sides by 29, and you get n is equal to that, which basically n is equal to 10. Okay, evaluate the following. Now, a quick revision in case you've forgotten. What does this mean? This means we are summing up 2k plus 3, but we're going to substitute in 1 first, okay? So you would do, for example, you would do 2, 1, 2, 1 plus 3 plus, then this counter would move up to k is equal to 2. So then you sub in 2, 2 plus 3 plus, and counter moves up to 3, and then we sub that in and add it together as well. So this is the formula for t of n, nth term. We need the sum of the first 20 terms. Now we're going to substitute in k is equal to 3, the third term. The third term will be given by 2 times 3 plus 3. And then so on until you sub in 20. This is the last term we sub in 20. 2 times 20 plus 3. Okay, that's what we have to sub in. So let's just write down 2 plus 3, which is equal to 5, right? So the first term is 5. And the last term, let's just sub in the last term. 2 times 20 is 40. 43 is the last term. Okay, 5 and 43. This is how you could do it in an exam if you've forgotten what it is, how it works, and so on. But let's just see how I've done it in the slide. So let's figure out the variables. The first term is you sub in 1. 2 times 1 is 3. 2 times 1 is 2 plus 3 is 5, right? Last term, you sub in 20 into that equation. So 2 times 20 plus 3. It's exactly how I just explained it a little earlier. So first term, last term, number of terms is 20. Do note that there was a specific formula for finding the number of terms, and I did mention it in previous lessons. You do 20 minus 1 plus 1. You always do plus 1. So the last term minus the first term, so 20, that number there minus that number there, and we add 1. Okay, so total, remember from lesson 1, total number of terms is equal to k minus a plus 1. K will be here, this will be a, and you always add the 1. So 21 minus 1 is 19, plus 1 is 20. You could count in your hands and see, check for yourself that if you sub in 1 to 20, number of numbers there will be between 1 and 20, including 1 and 20, there are 20 numbers. Alright, so let's sub into our formula. 20 over 2, 5 plus 43. So this is n over 2a plus l, the alternative formula. 480 is the total sum. Alright, so the third term of an arithmetic sequence is 15. The seventh term is 31. Calculate the sum of the first 10 terms of this sequence. So t of n, the third term, t of n, it's not the sum of the first 3 terms, it is the third term. So t of n is 15, and the seventh term. So t of 3 is 15, t7 is 31, and we have to calculate the sum of the first 10 terms, so s10. Now this bit is very similar to one of the harder questions we did in the previous lesson. So if you've forgotten, please do go back and revise. And I made specific mention of the fact that that question appeared a lot in trial papers and HSC papers and so on. So the third term, seventh term, using these we can figure out A and D. As I said, I did mention in previous lessons, it does appear in trial and HSC papers a lot. Alright, so the third term is that, seventh term is that. That is a simultaneous equation, exactly the same as the last lesson. We subtract t7 minus t3, the a's will disappear, you get 4d, because you do that minus that, a disappears. 60 minus 2d is 4d, that will be 16, and we solve for d. And if you solve that simultaneous equation, sub in all that stuff you have to do, right, you get a is equal to 7, d is equal to 4. And I do encourage you to try and solve it while you're watching. Do it now, right? Pause the video, do get practice solving it, okay? And then we just make these substitutions. We have the SFN formula. We know the first sum of the first 10 terms. So number of terms will be 10. 10 over 2. 2 times a is 7. 10 minus 1. The 10 terms 10 minus 1. D is equal to 4. Solve that in a calculator if you want. The answer is 250. Sum of the first 10 terms of the sequence is 250. This was a slightly harder question, but it's nothing that, you can probably expect this around question 12, 13, probably. This is not one of the harder questions. It's still fairly regular. It's just harder compared to, the stock standard ones. Alright, so example 6. This is probably something that you'd expect in the last few questions of an exam, of a trial paper. Let's just start doing it. Okay, so after graduating from uni, Butser found a job and started to repay his HECS government loan of $10,500. Let's assume the government doesn't charge interest. So we're not going to worry about interest, compounding, none of that stuff, right? It's just $10,500 and that's how much you owe and that's it. You don't have to worry about the value increasing. The compound interest stuff we will do later and it's very hard, but for the time being, we're just keeping it really simple, okay? In his second working year, he repaid $700. So the first year, he repaid $550. In the second working year, he repaid $700. The amount he repaid in each working year works out to be an arithmetic sequence. Now, before we even read this, they've given us, okay, it's an arithmetic sequence. That's the first working year he paid $550, so that's A. Second working year, he placed $700. Now, that is A plus D. We know A is $550. We can work out D. So, let's do that right now. Before, we know what the question is going to be about, right? It's an arithmetic sequence. In an arithmetic sequence, you need to know A, you need to know D. So let's do it before we even look at the question. We found out A and D. Alright, now, show that by the end of the fourth working year, Butser owed $7,400. Now let's start by finding out how much money he will have been paid by the 4th year. So sum of all the money that he's paid. In the first year he repaid 550. In the second year he paid 700, so it'll be 550 plus 700. And then third year will be 150 more than 700, 850. So we can use the sum formula if you want. We can just figure out the first 4 terms. Not that much of a hassle. So it'll be 550 plus 700 plus 850 plus 1000, I believe. If you do it just by adding d to 700, just add the difference to 700 one time, 2 times, and you get the third and fourth term. Or you can use the formula. So 3,100. If you add up all of those. The sum of money. Now, this is careful. Listen, this is important. He repaid 3,100. So the question was asking, how much does he owe? Not how much he has repaid. Now, he borrowed 10,500, right? He has paid back 3,100. So how much does he still owe? Well, we just minus it. We do 10,500, which is how much he owes overall, minus how much he's repaid, and he owes 7,400. Now, anytime the question says show that, or it says explain why, or anything like that, you need to show, you need to use sentences, you need to explain. Now, that's where this comes in. The sum of money which Batsa has repaid by the end of the 4th year is 3,100. Batsa still owes 10,500 minus 3,100 is equal to 7,400. So we have showed. They've given us the answer. So they don't want us to give them the answer. They've given the answer to us already. They want us to show why that is the answer. We have to explain that. And that's why we have explained it using sentences, not just numbers. In a lot of the harder questions, you will actually have to explain. Alright, so work out the number of whole working years. So that tells us the answer has to be an integer. Okay? They don't want a decimal or a fraction or anything. They want us the number of whole working years during which Batsa owed more than $500. He owed more than that, right? So he owes 10,500. When does he owe more than $500? Well, he owes more than 500 when the sum of money he has repaid is less than 10,000. Think about that. If he has repaid 10,500, he doesn't owe anything, right? If he has repaid 10,000, he still owes 500. So when does he owe more than 500? Well, when he's paid less than 10,000, right? If he's only repaid 4,000, he still needs to repay, 6,500 or however much it is. So we need to find the first year where he owes less than 500, right? Because then we'll know how many years he owed more than 500. So that might be a bit confusing. Just think about it. But basically, the equation I've made is this: S7 has to be more than 10,000. We're going to find when does the sum of all of his repayments equal more than 10,000. And as soon as we know that, we'll know. We'll stop at that point, -1, and we'll know, right? So, for example, on I don't know, the 50th year, he repaid more than 10,000. Well, in the 49th year, he owed more than 500 because he had paid less than 10,000 in the 49th year. Anyway, let's just go through it. So S of n, we use the formula, sub in everything we know. A is that, D is that, and we need to find n. We need to find the number of years. That's why that is still a variable. Simplify that, and you will get an equation like this. Now, this equation, basically, when I was doing this question, I first thought you might be able to factorize it, but it turns out you can't. You can use the quadratic formula, but then I said, well, hang on a second. The reason they asked us for whole working numbers is, we might just be able to use guess and check, because that's an integer. We sub in 2, 3, 4, 5, 6, and we'll get the answer. So solving that equation, for what year will he have owed more than 500? Well, we'll start by substituting in 5, because in the 4th year, from the first part of the question, we know he still owed more, right? So the 5th year, sub it in, it's negative 230, so it's not more than 0, so we're going to keep substituting. Let's sub in 6, negative 178. Well, the difference between this and this is not that big, so I'm going to sub in 8 now. I'm going to skip 7 and see what happens. Oh, well, it's still less than 0. Sub in 9, hey, it's more than 14. So on the ninth year, he will have paid back more than 10,000. So on the 8th year, he had paid back less than 10,000. In other words, he owed more than $500 in the 8th year. Alright, so some insight into harder questions. The HS exam and the trial HS papers are constructed to reward students who have a deep and profound understanding of mathematics. Right? They want you to be able to really understand mathematics on a fundamental level, be able to link different topics together and so on, right? Now, Band 6 students are expected to be able to think outside the box. You will be presented with questions which you haven't seen before. An example is that question there from the Sydney Boys 2014 unit trial. And you can give it a go yourself, see how you go, but the key is the length of the longest side is twice that of the shortest side. So T of n is equal to 2a. And that question I've never seen before. When I was looking through trial papers, I came across this question and I was like, whoa, that's a good question, you know. You really need to understand that the length of the longest side, T of n, the last side, is twice that of the shortest side. The shortest side is going to be a if it's an arithmetic sequence, right? Give it a go and you'll see. And it'll be a simultaneous equation. Anyways, link multiple topics together. You also need to be able to link multiple topics together. For example, just James Roos trial question. The interior angles of a convex polygon are in arithmetic sequence. The smallest angle is 120. The common difference is 5. Now, again, this is a very unusual question. You do need to know some geometry for this question. Find the number of sides of the polygon. So that formula for finding out the number of sides. And I guess my point is you need to be able to link multiple topics together. You also need to be able to solve new and unfamiliar questions like these two above. And that's just these two, but if you look at the 2018 HSC paper, the last question, it was crazy weird. It was really different. A lot of people got stuffed up on it. Very few people would have gotten it right. We haven't done that topic, so I don't want to put the question right here just yet. It was for this topic, but it was more geometric sequences. We'll do that in a bit, okay? Now, while your teachers will do their best to teach you the topics, the most important thing is to maintain a mastery of all content throughout the HSC. Maintain is the key word. We're doing this topic, make sure you don't forget it. Make flashcards, revise this topic constantly so you don't forget it. You must be equally good in all topics, because even if you love series and sequences, a trial paper HS question might link this topic with geometry. Now, are you good at geometry? Do you know all the geometric formulae? And you do need to know them, otherwise you get stuffed up when you have an unfamiliar question or you have a question which links multiple topics together. Similarly with the rest of the topics, not just geometry, it could be any topic really. Alright, so that's it, the homework. Make sure you do the homework sheet. That's it for today, good luck.